All right, so welcome back. Today we're going to finish up our discussion on counting concepts. All right, so we're going to talk about two specific type of concepts, permutations and combinations. Okay, so they are both calculated very similarly, and the equations to find them are very much alike, except for one small detail. All right, with a permutation, the order that you select the items matters. Okay, so it makes a difference what order you select items from the given set. A combination is simply just a grouping. And so it doesn't matter which order you pick them in, that group is going to be the same group regardless of which ones you pick first and which ones you pick second, and so on. All right, so permutation, order matters. Okay, combination, order does not matter. Okay, permutation is when I want to arrange them in a specific order, so typically you'll see words like arrange. All right, combination is more of a grouping. All right, so you just want to group them together. So each one of these has an equation that you can use to solve for. All right, but we need to make sure that we identify the different parts of the equation. All right, so for both of these, all right, we're going to use n to represent the total number of items that we can choose from, all right, or options from the set. So total number of choices, we'll say, okay, and r, lowercase r, is going to represent how many we're choosing from that group. Okay, so number being chosen. Okay, so n is how many choices we have, r is how many are we actually choosing. Okay, so there's two formulas for these. All right, and we're going to represent them using capital P and capital C. Okay, so on either side, we're going to write a lowercase n on the left and a lowercase r on the right for both permutation and combination. Okay, so the equation to calculate it is going to be this. For a permutation, it's going to be n factorial, okay, so remember n is the total number of choices, divided by the factorial of n minus r. So total number of choices minus how many we're choosing at a time, and then we're going to take the factorial of whatever that number is. So there's the equation for permutation. All right, for combination, it's very similar. It's also n factorial on the top, all right, and it has n minus r factorial on the bottom, all right. But the only difference in that one is that we're also going to multiply the denominator by r factorial. Okay, so that's the only difference right there in between permutation and combination, is that one little piece. All right, other than that, the equations are pretty much identical. Okay, so remember, n is the number of choices that we have, r represents how many are being chosen. All right, so let's take an example of, say that we've got a group of 10 students, all right, and these students are in a club after school, okay, and on one hand, we want to pick a group of 3 out of these 10 students to act as basically officers of this new club, all right. On the other hand, we want to actually assign positions to these 3 students. So we want to have one is going to be the president, one's going to be the vice president, and then one's going to be a secretary. Okay, so if I am going to do just the grouping, I just want a group of 3, okay, out of 10, all right, then that's going to be a combination because the order that I choose them in doesn't matter because it's going to be the same group. All right, so in other words, that if I choose Billy, Sally, and Jeff as my group of officers, it's the same exact group as if I choose Jeff, Sally, and Billy. All right, it's still the same 3 kids. Doesn't matter which order I choose them in, so they don't have specific positions or titles. All right. If I want them to have a specific position, or if it matters which order I choose them in, who I choose first, who I choose second, who I choose third, then that means I have to use a permutation. So let's say I wanted to assign a president, vice president, and secretary. All right, and I'm going to do a permutation. So that means I've got 3 slots to fill here, right? Okay. Now, if I have a president, vice president, and secretary, okay, and let's say that I choose Billy first, all right, and he's going to be my president. All right, Sally is chosen next for the vice president, all right, and then Jeff is chosen last as the secretary, okay? So this means something different if I chose Jeff first or Sally first and I made them the president, and then Billy was the vice president and either Jeff or Sally was the secretary. So if I choose them in a different order, it means something different because they have actual positions that they're assigned to. So that's what it means when order matters, okay? As opposed to the grouping where, again, Billy, Sally, and Jeff is the same thing as Jeff, Sally, and Billy. It's still the same group, all right? All of them are equal, okay? So to solve for this one, all right, I'm going to use my permutation. So let's say I have 10, all right, 10 students to choose from. So that is going to be represented by n, okay? So n is going to be 10 because there's 10 total students to choose from. And I'm choosing a total of 3. I'm choosing a group of 3, but order matters, which is why I'm using a permutation. So that's going to be R. So R is going to be 3. So I want to do 10p3, all right? I want to do this permutation. So let's go ahead and plug in those values. So I'm going to do 10 factorial, because that's n, over n minus R factorial. Okay. For a combination, all right, it's going to be the same thing. I'm going to do 10C3 this time. Okay, so let's go ahead and plug those values in. So I've got 10 factorial divided by, now don't forget this additional R factorial on the outside. All right, R is 3, so 3 factorial times n minus R factorial, which again is 10 minus 3 factorial. Okay, so with this one here, I can simplify. All right, 10 minus 3 is equal to 7. So now I've got 10 factorial divided by 7 factorial. Okay, and so if you recall from our lesson on factorials, all right, remember here I can cancel out terms on the top and bottom. So what's going to cancel out here? All right, everything from 7 down is going to cancel. So that the only thing that's going to be left is going to be 10 times 9 times 8, because 7, 6, 5, 4, 3, 2, 1 are all going to cancel on the top and bottom. And so that's going to be my final answer, which comes out to 720. So 720 different ways I can choose a president, vice president, and secretary when order matters. All right. When order doesn't matter, and I just want an equal group of 3, then I'm going to use this. So let's go ahead and simplify on that. So I've got 10 factorial divided by 3 factorial times 7 factorial. Okay. So here, once again, the 7 factorials is going to cancel out. So on the top, I'm going to end up with 10 times 9 times 8 again. And then on the bottom, the 7 factorial is going to cancel, but I still have the 3, 2, 1 on the bottom. All right, so then I go ahead and multiply that out. I've got 720 on top, and then I've got 3 times 2 times 1 on the bottom, which is 6. So 720 divided by 6. So now my total possible groupings of 3 would be 120. So you see a pretty significant difference in the amount of options depending on whether or not order matters. Here's one more example that we can take a look at when it comes to permutations and combinations. Okay, so let's say we've got a baseball team, right? And we've got 9 players on the roster. Okay, on one hand, we want to choose 2 of those players to be team captains for the season. All right. On the other hand, I needed to choose my starting pitcher and my starting catcher for the next game out of those 9 players as well. Okay, so which one of those is going to be permutation and which one's going to be combination? All right, well, if I am choosing the captains, all right, it doesn't matter which order I choose them in because they're both going to be equal captains, right? So I essentially need a group of 2 players out of that 9. So it doesn't matter what order I choose them in, so that one's going to be a combination. So let's start with that one. All right, so for a combination, N, remember, represents total number of choices. So I've got 9 players to choose from on the roster. So that's going to be your value of N. All right, and then I'm choosing 2 out of those 9 to be captains. So 2 is going to be R. So let's go ahead and plug that into our equation here. So I've got 9 factorial divided by 2 factorial times 9 minus 2 factorial. Okay, so let's go ahead and work through that and simplify. So 9 factorial on the top, 2 factorial times 7 factorial on the bottom. Okay, so what's going to cancel out here? Well, 7 down is going to cancel once again. So everything from 7, 6, 5, 4, 3, 2, 1 will be gone on the top and bottom. So on the top, I've got 9 times 8 left. And then on the bottom, I've just got 2 times 1. Okay, and then let's simplify. 9 times 8 is 72. And then half of that, there are 36 different combinations of captains that I can choose out of those 9 players. Okay. Now, on the other hand, I want to determine which one's going to be my starting pitcher and which one's going to be starting at catcher. All right. Now, since they're being assigned specific positions, then obviously the order that I pick them is obviously going to matter, right? So if I choose Damon to be my pitcher and Eddie to be my catcher, that means something completely different if I choose Eddie to be my pitcher and Damon to be my catcher, right? Because they're in different positions, so obviously it means something different. So it matters which order I pick them in, all right? So that means it's a permutation, all right? I still have 9 players to choose from, and I'm still choosing 2 out of those 9, all right? But since order matters, we're going to use the equation for permutation this time. So I've got 9 factorial on top, and then I've got 9 minus 2 factorial on the bottom. Okay, so let's go ahead and simplify. So that gives me 9 factorial over 7 factorial. Once again, 7 factorial is going to cancel out, and then all I have left on top is 9 times 8, which is equal to 72. Okay, so there's 72 total ways that I can choose a starting pitcher and a starting catcher out of those 9 players, because I can choose the same 2 players, but I can switch their positions, and that counts as 2 different groupings because the order that I choose them matters, which is why the number is twice as many as just the basic grouping. All right, so hopefully that was clear for you. If you're still confused, check out the PowerPoint notes. There's a couple of more examples in there for you to check out. There's also some good videos on Khan Academy. Please don't forget to get your homework assignments for the week, and we'll get some practice problems doing these probably tomorrow. All right, if you have any questions, shoot me an email or a comment in Google Classroom. Hope you guys are staying safe and healthy. Have a great day.